Given these considerations, we changed the strategy we were using to capture target T cells and acquired MHC Tetramer technology. In the following slides, I will explain MHC Tetramer and its application in this type of study. Over 20 years ago, researchers generated a recombinant peptide MHC complex conjugated to a fluorochrome in vitro. They then applied this monomer of the peptide MHC complex for detecting T cell targets. Nonetheless, the binding activity of the monomer TCR complex was too weak to facilitate detection of target T cells. The monomer was easily detached from the T cells. To overcome this difficulty, the monomer was biotinylated and tetramerized using fluorochrome-labeled streptavidin. It enabled the tetramer to maintain its interaction with the TCR on antigen-specific T cells. Here, we show the binding kinetics between TCR and the peptide MHC complex. The monomer of the peptide MHC complex sharply binds to the TCR but immediately detaches, while the tetramer binds to TCR very tightly and rigidly. Therefore, tetramerization is a valuable tool for detecting the peptide MHC complex, making it useful in T cell monitoring. This is how we synthesize MHC tetramers. First, we mix MHC peptide and beta-2M to make a monomer of the MHC peptide complex. Next, the MHC is biotinylated and purified by HPLC. Finally, the biotinylated monomer is tetramerized with fluorochrome-labeled streptavidin to form the MHC tetramer. So, how can you use the MHC tetramer? If you wish to analyze circulating T cells, it is extremely rapid and easy to use. First, collect whole blood, add the MHC tetramer, followed by a CD4 or CD8 antibody. Next, lyse the red blood cells and fix the cells. Wash once with PBS. Now you can analyze the sample using flow cytometry or fluorescent microscopy. For performing flow cytometry, we used two-color analysis. The double-positive cell population represents the target antigen-specific T cells. We will show you an example using a human sample in the next few slides. Here is an example of tetramer application in infectious diseases. This sample was obtained from a patient infected with influenza. You can detect the influenza-specific T cell using an MHC tetramer for specific flu antigens. The next example pertains to autoimmune diseases. This is a sample we obtained from a patient with type 1 diabetes. You can observe autoreactive pathogenic CD8 T cells identified using a tetramer against an insulin-related self-antigen. This is another example of tetramer application for a cancer antigen. Typically, the frequency of cancer antigen-specific T cells is very low. Therefore, prior to tetramer analysis, we needed to increase them. We performed this by stimulating patient blood cells with a peptide derived from cancer in vitro. After a 2-week incubation, we were able to detect the antigen-specific T cells using the tetramer. The applications for MHC tetramers in various areas of research are expanding. In particular, tetramers have various applications in the field of cancer immunity. The development of interventions, such as the dendritic cell vaccine, and treatments that use inhibitors of immune checkpoint molecules has led to exponential growth in this field. Accordingly, we are now expanding our Tetramer product offering to allow clinicians and researchers to evaluate more immune cells and other conditions.